Thank you.
Talk right now.
Yeah, it is already recording, sir.
Thank you.
Thank you.
Yeah. I would like to thank the International İZMİR Conference giving me opportunity to present my team's work. Preparation of nano-activated carbon from sewage sludge for wastewater treatment. So I'm from University of Namibia. The contents are introduction, objectives, methodology, characterization of the samples, results and discussion, conclusion, acknowledgement and references. The sewage sludge, it is a thick, soft, wet, mud or viscous liquid or solid components it can be, and especially the product of an industrial or refining process it is. And this comprises of both inorganic, organic components, and this contains about 50 to 70% of carbon. So the activated carbon is prepared by high carbon content, and it is used for purification of liquids and solids and other contaminants. With an increase in pollution of water sources, there is increase in population, challenge for water utilities in Namibia and throughout the world in underdeveloped countries or developing countries as well. So thus an alternative cost-effective waste is to be acquired in supplying clean water. So one of the cost-effective water treatment technology is preparation of activated carbon from any material for water purification. So from the literature point of view, it has been found that AC was prepared from sludge with the addition of foam balls in a solution of sulfuric acid, zinc chloride, NaOH, or potassium hydroxide. So what is the significance of this research? So clean water is a basic need to all Namibians at a global level as well. And various reasons are namely for consumption, cooking, keeping on clean self, industrial purposes, also at domestic level. So with the increasing population in these countries, unpredicted droughts, there is a challenge for water utilities. That is to meet the demand of clean water for all those needs in developing and underdeveloping countries as well. So the objectives of this study is raw water quality in terms of dissolved oxygen content, carbon, pH, conductivity, and TDS, total dissolved solids. So to establish the efficiency of this activated carbon, that is in removing the above mentioned parameters. And the prepared activated carbon is characterized by FTIR, infrared spectroscopy, scanning electron microscope, Brunner, Emmett, Teller, BET, transmittance emission microscopy, and ultraviolet techniques, ultraviolet spectrophotometer. Methodology here, sample A of AC and B are prepared by addition of the foam balls in zinc chloride and dry sludge. Second method is prepared by dry sludge directly by carbonizing in furnace. Yeah, preparation of activated carbon. First, the foam balls are taken, and to it zinc chloride is added, where it will be coated around, and adding these foam balls to the sludge. So once it is added to the sludge powder, these foam balls, then it is carbonized at a high temperature between 400 to 500 degrees centigrade for 1 hour. Then we see that foam balls are coated with activated carbon, and it is used for wastewater treatment. Data analysis and parameters, what have been measured in this case, in this study, infrared spectrometer, scanning electron microscope, BET surface area, ash content, moisture and yield, pH, iron water, and 0.2% methyl orange. And for water treated samples, they are analyzed by UV spectrophotometer. Results and discussion: ash, moisture and yield content for sample A and B. Ash content for sample A was 58.8, sample B 75%. Moisture content for A was 31, for B 12, and yield was for A 45% and B 52. So here the moisture content decreased for the sample B a lot. We can see by 12. That means that it is carbonized here. Some moisture might be there in the sample A. Then pH for the both the sample AC and AB. If you see, first one is the A, 25 degrees centigrade 6, 50 degrees 6 to 7, 75 6 to 700 6 to 7. So after 25 degrees, the pH has been almost constant in increase, but remained constant. That is around neutral it became. And for the sample B, initially the pH at room temperature was 5. At 50 degrees, 5 to 6. At low temperature, it is remaining acidic, as in the case of the sample A also we have seen. But as the temperature is increasing, the pH is increasing, and it's neutral. And from the graph also, it is represented. Density, we have seen the density for this prepared activated carbon, A and B sample. They are powdered samples, amorphous samples, compressibility is more. So by tapping method, we have done, we taking in the measuring cylinder and tapping a number of times. So you can see it's almost constant from the 50 taps. Initially 0 tap, initial reading is taken 0.5 only, but after that, till 200 taps we have done, and the density remains constant, 0.6, like that. So that means the compressibility is good. It is pressed very well. Uniformity is there in the sample. Same for the B sample, we have observed from 75 taps, it is constant. So these are the samples. We have the standard orange one, methyl orange, and after treatment, we are getting the clear solution. And these are for the low concentrated, low loading with the MO. Conductivity and TDS. Conductivity, blank distilled water showed 3.6, C raw water showed 27, Gammam's water showed 1.4. So from the conductivity point of view, from sea water, you can see how much salts are there. So it will naturally it will give more 27. That is the reason. Then after treating with the AC, that conductivity 27 of the raw water became less when treated with the sample A 18.1 and Gammam's water 1.1. Then sample B also, it marginally decreased 22.3 and Gammam's water 0.8. And from this result, it is evident that sample A is more, it will eliminate the salts and all, whereas sample B bit marginally, because it was carbonized directly without impregnating with zinc chloride. And TDS, total dissolved solids. Solids are how much they are dissolving. Gammam's water 50 ml, 0.05, it was good. Sea water 1.7 and tap water 0.004. So that means from this study, it is evident that Gammam's water is having less salts, whereas compared to sea water, as we already know that it has a lot of salt. So TDS is not good for the sea water. Yeah, FTR, infrared spectroscopic studies we have done for this sample, comparing with the standard samples. From the graph, from the spectra, it is evident that the sample A and B showed 1084.77 CO stretching. That's it for acids and alcohols and phenols, and sharp band at 21. Here it has 68. It has shown due to the triple bonds, carbon C triple bond. Then at 1034.57, it shows stretching vibrations of carbon, oxygen, and carbon. SEM analysis, scanning electron microscope of the activated carbon prepared from the sludge. The SEM analysis shows the morphology of the material, whether it is spherical or spongy, or that pores are formed. From this study, it is evident that the nanopores are formed. Many are formed, and the white patches which we are seeing that are assumed to be zinc chloride, and it is matching with the reference. Then For the sample B, external and internal surface, if you see closely taking one sample and monitoring, pores are visible, and with that some zinc chloride is still visible. Transmission electron microscope, this gives the whole picture of the material being nanoporous or not. You can see the lot of pores, small pores are formed, nanopores. It is evident with the aggregation of this, pores are being formed. Then external and interior, these nanopores are well formed. After that, one particular sample is taken and it has been magnified by the technologist, and you can see the thin sheets are being formed. Then finally, we have some results of the iron water, Gamams water, and sea water. The blank distilled water gives a plain line in the left side at the top. Then the right iron water, raw water is there, the black one which shows, and comparing with the treated water sample A and sample B, straight line is being formed from 400. You can see it has been removed, iron. Then same we are seeing for the Gamams water sample A, sample B. Raw water is matching with the treated one, but from 300 it has decreased, and sea water also from 230 it has decreased. In conclusion, activated carbon was produced from waste sludge with zinc chloride as a chemical activation. The prepared AC was then used to treat wastewater. The activated carbon prepared from sewage sludge was giving positive results for 0.02 MO and Fe contaminated water, Gamams water, and sea water. In summary, from these results, it is evident that environmental clean water is developed for wastewater treatment. I would like to acknowledge the İZMİR International Conference organizers for giving me and my group opportunity to present my work, and the University of KwaZulu-Natal in South Africa for characterization of the samples, SEM, TM, and FTR, and finally the School of Science at the University of Namibia, particularly the Physics, Chemistry, and Material Science Department for providing research facilities. And finally, I appreciate and thank my students for carrying this research and co-supervising. These
Thank
are
you
the
so much.
references. Thank you.
Thank you, Dr. Ateeq Rahman, for your presentation. We have now time for 1 or 2 questions from the audience.